The broadcast is now starting. All attendees are in listen-only mode.
Well, good morning, everybody, and welcome to this morning's session from Smart Vision Europe. Today, we're talking about predictive analytics. This is a regular session that we run every few months or so. My name's Jarlath Quinn. I'm an analytics consultant. I'm joined online today by my colleague, Rachel, and Rachel will be fielding questions and making sure everybody's logged in correctly as we're going along. If you haven't joined any of these sessions before, if this is relatively new to you, then just a few housekeeping questions to deal with. First of all, we do record these sessions, so you can listen to them again afterwards. And with regard to the slides I'm going to be using a slide deck this morning to introduce the topic before we do a demonstration. And we always email out a PDF copy to you after the session is ended. If you think this is something that's useful for your colleagues who perhaps aren't able to attend today, and you'd like us to arrange a rerun for it, perhaps on a private basis, it might be possible for us to do that, in which case just ask us. And with regard to asking questions, well, all the lines are muted, so we ask you to use the chat facility, and we'll try and answer questions as we're going along, but obviously if we run out of time, we'll follow up with you offline, and obviously you can contact us offline anyway and send emails, etc. Give us a call, and we'll be happy to answer any questions that you might have. So as regard to who Smart Vision are, we are a technology organization. We're a relatively small organization, and we specialize in advanced analytics. So we're a premier partner to IBM, specializing in advanced analytics. We're also a gold partner to SAS, and we have a relationship with something called Blue Sky Statistics, and we provide a full suite of support and training. So that means we provide software and we provide services around that, and we're made up of a team who each have about 15 to 25 years of experience working in the advanced predictive analytics space. So I, for example, have worked for SPSS, IBM, and SAS as a senior consultant in statistics, data mining, data science, all those sorts of areas. And if you're confused by those different areas, we're going to try and deal with that later on in the session today when we start defining predictive analytics and what we mean by all of these different terms that refer to advanced analytical capabilities. So if you look that term up, for example, in Wikipedia, the term predictive analytics, what you get is this definition where it says predictive analytics encompasses a variety of statistical techniques, from predictive modeling, machine learning, and data mining, that analyze current and historical facts to make predictions about future or otherwise unknown events. And the point that Wikipedia is making there is that predictive analytics is very much a banner term that encompasses lots of different analytical techniques, effectively, from different traditions, such as the machine learning or the data mining tradition or statistical tradition. And this would encompass things like data science as well. So they're all pretty much part of the same smorgasbord, if you like. IBM talk about predictive analytics in terms of the analysis of structured and unstructured information. So unstructured information referring to not quantifiable, not quantitative data like structured data such as numbers and numerals, but rather text, video, images, audio, that type of stuff. There's a lot more unstructured information out there than there is actually structured or quantitative data. So it simply makes the point that predictive analytics incorporates the analysis of unstructured information with things like data mining and predictive modeling, and also what-if analysis in there. Now, we prefer to try and address predictive analytics by thinking about it in terms of a series of bullet points, because it's quite hard to come up with one snappy definition that really incorporates everything. First of all, it is a banner term in the same way that business intelligence is a banner term for things like management information reporting or dashboards or online reporting systems. But it's different from BI or MI reporting, and we're going to see how it's different from those two approaches. One second thing is it's not actually, ironically, always about prediction. Ironically, predictive analytics isn't always about prediction. It's often about things like anomaly detection or segmentation, trying to find similar things, not necessarily predicting an outcome. But one of the things that makes predictive analytics quite different from BI or MI reporting is that it creates new data that didn't exist before. So this is very important, and this new data is really how we evaluate the worth of a predictive analytics application, because the new data takes the form of something that's been created by a model. So something like an estimate, a probability value, a forecast, a recommendation, a propensity score, classification, a risk score or a likelihood value. So it's creating these new data for us. And what we do with that new data is that we tend to send it to some sort of operational system to make a decision, and or some insight system such as a BI or MI tool or visualization tool, so that we can see how, for example, propensity scores or forecasts or risk varies across different groups in the same way that we might see how profit or revenue varies across different groups. So the acid test of predictive analytics is very much focused around these new data that it creates and what we do with that new data. So that's one of the things that makes it very, very different from BI or MI. It's not just about insight, it's about giving us information or data that will allow us to make a better decision. So as you can probably imagine, the term predictive analytics has been trending upwards for some time. It's actually probably leveled out round about now. So we should bear that in mind, because of course there are many other terms relating to advanced analytics which are out there. So for example, when we look at terms like business analytics or data science or machine learning, you can see that they very much dwarf predictive analytics in terms of their popularity, the search trends within Google. But really, they're all kind of talking about the same thing to a certain degree. Predictive analytics is a banner term for these. Machine learning and data science are very hot topics at the moment, but they're often very much talking about the same thing. They're talking about analytics that produces data that allows us to make a better decision. Okay, so we should bear in mind, of course, that the dreaded term big data is there as well. And actually, round about now, I think if we update this chart, the term machine learning has now surpassed big data in terms of its popularity as a search term. So it's pretty important. We should bear in mind, of course, that machine learning tends to incorporate things like, tends to be used almost as a synonym of artificial intelligence or AI, and they're not quite the same thing. Machine learning, when we talk about machine learning here, we're talking about algorithms that produce data for us in the same way that we were talking about a statistical predictive algorithm that produces new data for us, new data in the form of prediction or an estimate or a risk score. Okay, when we look at where predictive analytics applications are actually applied, certainly within the commercial realm, if we take an example of a commercial realm where individual people are customers of a commercial entity as opposed to businesses, the core sort of predictive analytics applications you get are around trying to attract the best new customers. So these are very much about growing your customer base. Who should I be advertising to? Who should I be contacting? What is the profile of the people who become our most loyal or our most profitable customers? So the output from the predictive analytics model, if you like, is to give us a number or a score or a value that tells us that that this is the correct person to contact, or that this person is a good prospect for becoming a customer. Alternatively, you have applications around growing people's understanding, their intimacy, or their share of wallet of a customer. So looking at what other services can I sell to a customer, or are there certain affinities, are there certain products which would help me grow my share of wallet of that customer. So we're really talking about things like cross-selling and upselling here. And of course, there are lots and lots of applications that look at the portfolio of services or products that a customer has purchased in the past, combined with their demographics, combined with their behavior, that produces a recommendation that says, okay, you should offer this person this service or this product, or this is what you should do to maintain, to maintain their business. And speaking about maintaining the business, we have a lot of applications around retention, around customer retention, often referred to as churn analysis. And it's been shown that retention can be very, very cost effective, because very often it's more expensive to attract a new customer than it is to retain a customer. So retention modeling is particularly powerful and particularly compelling when we're dealing with businesses where they know who their customers are. So any businesses where you have an address of that customer, so that's just a power utility, or anything which is very much subscription based, where there's a renewal contract such as Netflix or a telephony or mobile phone contract, or anything like that, that's very powerful. But retention is also applied to things like retail, where you may not necessarily know that customer, but where you see a certain credit card that has been occurring and appearing in your shops for the past, on a regular basis for the past 3 or 4 years, and then suddenly it doesn't seem to appear anymore, or that person's name doesn't seem to come up anymore. Retention can be a key area there, and this is one of the reasons why retailers have things like loyalty cards, so that they know who people are. So in this case, the outcome is a prediction that says how likely this person is to remain a customer. And obviously, if they have a very low likelihood of remaining a customer, one hopefully can take action to keep their business. And then on the darker side of it, we have applications associated with risk. And risk, normally risk modeling when you're dealing with customers, refers to things like credit risk. So it's the risk that that they won't pay you back, or that they will default on a payment, or they'll miss a payment. So there's a lot of applications around credit risk, particularly when acquiring customers, retaining customers, or when offering them services whereby you're relying on them to pay you back, such as a loan, for example. But there are risks associated with assets, so risk of failure, or risk of the business being able to fulfill an order, for example. So risk can incorporate anything which is going to hurt the business, or hurt the business's relationship with the customer. And the fifth area tends to be fraud. So fraud is a huge area, but that could incorporate things like credit card fraud, identifying transactions which are fraudulent, identifying phishing activities, or logins, or access of networks which is fraudulent, identifying patterns of behavior within retail stores that indicate that there's staff fraud going on. This is a huge area, and it's a particular area because very often it requires different approaches from the other areas. So very often fraud is difficult to detect because it hasn't necessarily been recorded from the data, and therefore things like anomaly detection, where we're looking for unusual or anomalous events, are incorporated as a predictive analytics tool to identify fraudulent behavior, or clandestine behavior, or fraudulent transactions. So these are the typical applications one gets within a B2C environment, where it's a business to customer. There are very similar applications, of course, and it's not difficult to imagine how that would work in a B2B environment, where the customer is not a person but another business. And it's also possible to imagine how in certain not-for-profit organizations, such as charities, a number of these applications are still quite valid for charitable or even public sector organizations such as local government or central government. Okay, so when we look at, again, back to the commercial realm, when we look at typical application aims, if we're thinking about the sorts of the titles that people would have to describe a predictive analytics project, we can think of this in terms of the two primary areas of controlling a business, which is trying to maximize your opportunities and minimize your risk. And certainly within the dimension of opportunities, we tend to see businesses focusing on growing their profits, growing their margin, if you like, and also growing their market share. So that means growing their revenue. On the defense side, where they're defending their business, they're defending it in terms of they're defending their market share and defending their profits. And it's almost as if when we look at a annual report for a business, and you can go online and pick a business and you can say, okay, what's the annual report for this business? You will very often find that these application aims fall out of that annual report. So you will see things like, in growing profits, they want to lower the cost of acquiring a new customer. So they want to make that cheaper, more efficient by perhaps not not marketing or not spending effort and time trying to convert prospects to being customers when they have a very low likelihood of doing so. So they want to increase their share of a customer through cross-sell or upsell, so share of a customer wallet, or they want to maximize lifetime value, so they make their customers more profitable. And then with regard to market share itself, growing revenue, they want to acquire more customers. They want to look at building a reputable brand, so they're looking at perhaps unstructured data and looking at what people are saying about that brand. So there's a lot of supermarkets, for example, that monitor Twitter feeds and and see what people are talking about them in response to newspaper articles, in response to advertisements on the television the night before. Anticipating demand, so again within retail, trying to anticipate demand for certain goods, products, means that that availability is increased, and that therefore they're likely to grow their market share or grow their revenues. And that maximizing satisfaction, identifying what drives satisfaction. Being able to maximize these things all indicate that there's opportunity there. And on the risk side of it, of course, defending the profits, if you like, they're trying to minimize defaults, trying to minimize people not paying them, trying to prevent fraud, trying to prevent waste, trying to prevent shrinkage within retail. They're trying to maintain availability of websites, of ATM, of equipment, of vehicles, of machinery. And then with regard to defending the market share, it tends to be things like maximizing the loyalty of the customer, addressing poor satisfaction, lowering churn rates, or perhaps reactivating passive customers, i.e. customers who haven't technically churned, but who haven't also done business with the organization for some time, and thinking, what sorts of things will actually reactivate them. So again, these map very directly towards typical sorts of aims and objectives one would see in a lot of annual reports. So you can literally look up an annual report and you will see these sorts of bullet-pointed aims for the business over the next year. And what that's doing is it's suggesting predictive analytics projects to use. Very often businesses don't know where to begin with regard to predictive analytics. They're interested in it, they don't know where to get started, and very often it's right under their nose. All they have to do is look at their annual report and they will see these potential applications being suggested to them. So for example, here we have a leading international retailer talking about, these are some I've picked off the internet, growing our core business in existing markets through service, value and innovation, continuing to deliver productivity improvements and other cost savings. Where is waste occurring? Pursuing growth opportunities in selective new high growth markets, identifying, that's very much about identifying profiles of customers who are likely, to become, profiles of prospects who are likely to become customers and who are likely to become profitable customers. And then a charity organization investing in expanding community fundraising in new and existing markets for unrestricted income based on analysis and business plans. That's a predictive analytics application. They're based on analysis and business plans. Maximizing individual and institutional funding markets by developing innovative products and channels, compelling messages and best practice. What is the best way to interact with potential donors? What is the best channel? What is the best practice? What is the best message? What are the products that we should be showing them? These are very, very much open to being decisions that are data-driven and therefore predictive analytics. So again, these are directly from annual reports for organizations I've just picked off the internet. Here we have a major UK home improvement retailer, and they've talked about expanding customer reach and building loyalty, developing large-scale customer data collection, insight and personalization capabilities, investing in systems to drive online sales growth, improve promotional effectiveness, and selectively invest in pricing. I've literally done projects looking at what sorts of promotions work best within a retailer. So, trying to figure out what is the combination of messaging, of circumstances that lead to people redeeming vouchers, that lead to them increasing their basket size, providing high levels of availability to our customers. There are certain retailers out there that are running predictive analytics applications, mainly forecasting applications, that will forecast or predict at the level of the SKU, i.e. at the level of the individual product, the likelihood of that product selling out within a store within a given week. And given that they have hundreds of thousands of products in a store, and they may have hundreds of stores, that means that they're dealing with millions of forecasts which predict the number of sales, the amount of sales that they're going to have of those products, and they will automatically update their fulfillment warehouses so that they will order new products for them based upon those scores. So that is literally about providing high levels of availability to our customers. You wouldn't shop at a supermarket if it constantly ran out of milk. You'd probably go elsewhere. So there are certain products you absolutely have to make sure are available to the customers at all times. So typical predictive analytics applications, we're starting to zoom down and narrow it down a little bit now into specific sorts of terms or applications from a data mining, from a data science aspect. So with regard to segmentation, you will hear terms like cluster analysis being used. And cluster analysis is a technique, it's a segmentation technique, which clusters together similar customers or similar events. So cluster analysis is used to say, this is what the data shows about our customers. These are the different groups of customers that we have within our database. And that could be in order to drive lifetime value. It could be to identify, segment customers in terms of the loyalty. I've done a few projects where we've actually segmented or clustered together similar stores within a retail organizations. So we can say, well, these stores have the same profile, so we should stock them in the same way rather than just based upon the amount of space that they have. And then predictive modeling, very much what we talked about already, predicting an outcome, people's likelihood to respond to an offer, customer acquisition, cross-sell, upsell, retention, asset failure, that type of stuff. There are a few other applications out there which we'll see an example of in a minute, such as basket analysis, sometimes called affinity analysis, identifying what products tend to get used together, forecasting, sentiment analysis, we're looking at what people are saying about an organization or about a product and what their sentiment is, root cause analysis in things like asset failure, so to identify availability. And these are typical sorts of applications one would get within predictive analytics, and of course they map directly back to the sorts of business objectives we were seeing earlier on. So let's just talk about how predictive analytics works in a nutshell in terms of modeling, if you like. So predictive analytics uses historical data from many people or many incidents, generally speaking. So you've got historical data, it's in the past, and the data is comprised of, for example, things like their demographic details, such as their age, gender, some transactional details, their average spend, what was the last product category or what product categories have they shopped in, their region, their tenure as a customer. So there's a whole bunch of different factors in there. But what's normally focused on is some sort of key outcome or result, such as they responded to an offer, they upgraded to a better service, they defaulted on a payment, they recommended us to a friend, they cancelled a subscription, they donated, a system failed, they renewed a contract. So we've got historical outcome, historical data with known outcomes, known results. Some of the results are good, some of the results are bad. And we use those to build a reusable model, as we'll see in a moment. This model we can think of as an object. So this model is just an object that is either a formula or a pattern. And we can examine that model. We can see how accurate it is and how well it works when we try to get it to predict outcomes on data perhaps that we've held back, test data. And we can even treat it as an asset in the sense that we can archive it, because it will only have a certain lifetime value. You wouldn't expect a model that was developed in 2014 to necessarily still be working in 2018 in a lot of situations, because the world has changed since then. So you may retire it, you may refresh it, you may change it. But the point of this model is that we can take new data from individuals' incidents, And the new data will, of course, be comprised of, again, demographic information such as their age, gender, the average spend, their sentiment, their tenure as a customer, the time since last visit to the store or the website. And using a model based on the same information, the model generates these new data that allow us to make better decisions. So that new data takes the form of probability values, likelihood scores, or estimates. In other words, predictions. So the model's kicking out values to us like, we predict this person's lifetime value to be £938, or there's a 32% chance they're going to cancel their subscription, or there's a 0.13 probability of defaulting the payment, which would be a 13% probability of defaulting the payment, or the estimated net promoter score, the likelihood to recommend this to a friend or a member of the family is 6 out of 10. So this number that we produce then allows us to make decisions. And we take this number and we try to deploy it in some way. Now this is where it starts to get quite interesting, because what we do with that number is critical to the success and the usefulness of the predictive analytics project. And we should really be thinking about very, very far ahead of time what we're going to do with it. So for example, the model may be deployed to send out emails to people, and it may be dictating the content of those emails based upon their segment, or based upon what is the next product or service we should offer them, or based upon their lifetime value. Or it may be that the model is sending out something physical in the mail, such as a letter or a brochure or a flyer, in which case there may be a physical cost associated with it. Or it may be that the model is scoring a database at 2 o'clock in the morning, because the model's job is simply to produce these scores, and then another system comes along and takes care of it. The marketing department, for example, come along, take care of it. And really the job of the analyst is to make sure that the latest scores, the latest probability values are on the database at a time that people can take action on them, and that shouldn't mess everything up. So it's done in the middle of the night. Or it may be that the model is used to produce values or scores that are then displayed within an insight system, a visualization system, such as a heat map that we can see here in the top right-hand corner, where we can see propensity to accept a discount card based upon age group and the number of previous purchases. So it's really being used to drive insight. Or maybe the model is being used to surface content onto a website to make a next best recommendation. Or maybe the model is being fired in real time in a call center environment where somebody is called in, or a customer number is asked for. The model makes a prediction, and the model recommends that you should offer them another product, but then the person says, I don't understand my last bill, and the person the call center operative types that into a system, and the model then parses that text and produces a different recommendation, or a different model is fired to produce a recommendation. Actually, it says this person is now a churn risk, they're a retention risk, and you should offer them a discount. So that's a real-time interactive model being fired there, and it's obviously very different. So you can see how the modeling is not just about statistics and about accuracy and producing predictions. It's really about the decisions you're going to make with that model. How are you going to use it is critical to its success. Okay, so let's look at a little example here. We've got a little example where we've got a person here. She's called Anna, and she's 31 years old. This is what we know about her. We estimate her income based upon geodemographics, or based upon her spending or whatever, to be greater than £28,000 a year. On average, when she visits the online web store that we have, she spends £26. She usually pays with her credit card, not always, but sometimes her debit card. She just either hasn't been a customer long enough, or she hasn't spent enough money to be eligible for the big discount offer that we have this month. And in the last 6 weeks, she's bought these items. And when she comes onto the website, currently our current approach has been just to show whatever happens to be the sort of thing that we're trying to promote that week. It's something from our brochure, or something from our flyers, or marketing creative department. But what we'd like to do is we'd like to offer her something that is relevant to her previous purchase pattern, and relevant to her, let's say, her demographics. So rather than just offering her something random. So we've got this problem, and the way in which we approach that problem is if we go out to a data mining tool, like this one. This is IBM SPSS Modeler. We can see some data that's kind of similar to this. So if I show you what the data looks like, this is on a database. It's just it could have been a flat file, it could have been an Excel file, it just happens to be in a database. And it's very, very simple data. So I'll show it to you. I'm showing you the top 10 rows of data here. Here we have it. We have an ID field. We have the average amount of money people spend. We have method of payment, pretty outdated now. We've got some checks in there. And we've got their gender. We've got whether or not they're a homeowner. We've got their estimated income and their age. And none of that's actually important. We don't actually need any of this information for our modeling. What we need for our modeling is we need to know what product categories they have previously purchased in. Because it turns out, you know, there's a number of different images we can show on the website from different product categories, different parts of our portfolio or inventory of products. And if they say T, then it just means that within the last 6 months, that person has bought something from the travel section and they've bought something from the kitchen section. Here, if it says false, it means that they haven't bought anything from these sections in the last 6 months. So you can imagine how, you know, getting this data into this format is for most retailers, that takes a bit of thinking about, because a lot of retailers will have very, very finely grained, very, very fine taxonomy of products. And here we've got a very, very simple taxonomy. You know, we're not going down to, we haven't got, you know, 5,000 different product groups, something like that. So you can do that with the approach we're going to show in a moment. But for illustrative purposes, it works best if we just got a few little simplified product category here, taxonomy here. So if I run the web plot here, I can show you the relationship between these products. Now, if I run this web plot, you can see that this is a visualization of the relationship between the products that we've just seen. And the visualization is simply showing that the thicker the line, the stronger the relationship, because here we have 144 links of people who in the last 6 months have bought kitchen and dining. But if we look at kitchen and bathroom, it's only 54 links. And here we have a three-way relationship between gardening, electricals, and home office. You can see that if you buy gardening, you tend to buy electricals. You buy electricals, you tend to buy home office. You buy home office, you tend to buy gardening. And here we have a relationship between living room and textiles. It turns out we can actually play around with this. We can change what we regard as an important link. It's not just so arbitrary. We can play around with our own arbitrary values. And I can define what is a strong or a weak link by masking out the stronger or weak links. And I can actually interact with this and say, okay, go and select, say generate select node, and go and select everybody who bought kitchen and dining. It creates a little node for me up here, a little symbol or icon. And if I show you that, you can see that everybody in here will have bought. Oh, let's have a look at that. It's electricals and living room. Sorry, not kitchen and dining. Electricals and living room. I've clicked on here. So all of these people here have bought electricals and bought something from the living room category there. So what we want to do is, instead of just visualizing this data, as we're doing here, we have this sort of overview of the different flags. You can see these fields are just trues and falses here. It's just showing me how many, but this is the trues, this is the falses, telling me what proportion. There's only 1,000 records here for illustrative purposes. What we want to do is we want to operationalize these relationships so that we can make recommendations as to what's the next product we should show these people. So very similar to the example we have there of Anna. And I can connect an algorithm up here. So it's a model building. When we talk about algorithms within the realm of statistics and predictive analytics, we're talking about tools that help us build models. In the media, they seem to use the term algorithm to mean anything, just anything which is rule-based. They very often seem to confuse the term model with algorithm. But algorithm here is something which builds a model for us. Now I'm just going to change a couple of settings here. In the same way that I changed the sliders in the charts there, I'm going to change the settings here. So I'm going to say this should apply to at least 8% of the data, and it should be at least 30% confident. If I run that, it produces instantly for me a nugget, which is a physical model. If I look inside the model, you'll see that it's made up of a number of columns, and these columns are effectively rules. And the first two columns refer to something called consequence and antecedent. But that just means before and after. That means if you bought electricals and gardening items, then you've probably bought home office as well. 17%, the support value here refers to the antecedent, 17.7% of the data have bought something from electricals and gardening. And off that 17%, 87% of the time, they've bought something from home office. So the first three rules we see relate to those that triangular relationship that we had between home office, electricals, and gardening. So it's like, if you bought home office and gardening, you probably buy electricals. If you bought electricals and home office, you probably buy gardening. And down here we have a relationship between kitchen and dining and kitchen. That's saying, if you bought kitchen, and there's a 29% of people have bought something from the kitchen category. 52% of the time when they buy something from the kitchen category, they buy something from the dining category within the same 6 months. If they buy something from the dining category, 50% of the time they buy something from the kitchen category. So it's finding these natural relationships, and you can see here it's found 22 rules. I could change this and say, no, I want to find more rules. And I've done exactly this with with clothing and retailers, where you're dealing with thousands and thousands of people. So I could, for example, here kick the rule support down to 4% of the data and say, I want rules to apply to only 4% of the data. Double click on it, and now I've got 88 rules. So it's going down into deeper, smaller groups. You see, we've got support now down to group size of about 9% or something like that. So you can control how many rules you're going to get. Now, what does that physically produce for you? Well, these model nuggets have to produce, as I say, new data. That's the whole point about predictive analytics. So when I run this, here is the original data set. It's 1,000 records. You've seen a little preview of this. This is the trues and falses. But along the end here, we have new fields that have been created that have dollars in front of them. The dollars indicate that it's been created by a model. And here it's saying, I recommend you offer this person something from the dining category. Why? Because there's a 52% chance they'll go for that. And that has a rule ID. That's rule number 44. If, for example, you didn't want to do that, you've got a backup rule, which is rule number 69. And that is offer them something from textiles. Why? Because there's a 35% chance they'll go for that based upon their pattern of purchases. Here we have living room as a third option, and we can control how many recommendations it makes us. 31% chance, and that's rule 76. Here we have a case where it says null, null, null all the way through it. That means that they haven't bought enough within the historical data to fire any of the rules. They just haven't purchased enough products. Here we have an example where it's got one recommendation, but not a second or a third recommendation. So it really is quite rich. Now, if you were being very clever about this, we could perhaps take these values here, multiply them by the margin, the average margin of profit that we make on textiles. And that would tell us whether or not we should offer textiles where we make, let's say, £30. We've got 30% of £30, versus living room where we make £50 margin and we're getting 30% off £50. So you might end up offering living room. But you can imagine how these just having these recommendations out there will help us figure out next time we see this ID or this cookie, let's say, appear on the website. All we've got to do is have the web system look up a table, this table, and say, well, what image should we offer this person? What is our next best offer? And it would simply pull from the table the requisite or the required image to show that person to drive that offer, which of course is exactly how platforms like Amazon work when they say other people who've bought this product tend to buy this product as well. So in Anna's case, if we look at Anna here, we could see that we probably end up, given that she's bought two things in the kitchen area here, we probably offer something from dining, since that's quite a strong rule. Now, before we finish here, I'm just gonna quickly jump to another example, very quickly, another example here. And this example here, instead of looking at the relationships between variables in terms of their affinities, their natural affinity, instead here we've got one key outcome. So this is a slightly different situation. Here we've got one key outcome, and here the audit node that we're seeing is coloring the groups by that outcome. And the outcome is a 1 or a 0, the one indicating that the person redeemed an offer, redeemed a voucher. They were given a voucher and redeemed it. And we can see here, for example, just from our exploration of the data. This a BI tool could perhaps do this. We can see that people who are younger tend to be more likely to redeem it, because as we got the age group, the proportion that redeem the voucher seems to be smaller. So that might be a good predictor of people who redeem this voucher. But what we're going to do is we're going to build a model, and we're going to test the model. We're actually going to hold back some of the data. So here I'm holding back, you can see it says 50-50 down here, and it says training and testing. That creates a random training and testing split within the data set. And what it will do is it will build a model to try and predict what is the likelihood that somebody will redeem a voucher based upon their patterns of behavior and demographics. And then it will test it against the test group and select the best model. So there's a lot going on in there. This is a classic way for us to predict an outcome. It's called a classification model. And as we can see here in Modeler, there are lots and lots of different classification algorithms. So it might be a bit bewildering to you as to which one to use. So as a result of that, we've got something called an auto classifier. And the auto classifier tries out all of these different algorithms. Here they all are. I'm going to try them all out for us and pick the best one based upon what's called the lift value, based upon their performance in the test group. It's going to pick actually the best top 3. So I could change top 4, top 5. I'll say top 3. Just show me the top 3 models that you have built based upon their accuracy or their lift value on the test group. That's the 50% we've held back. So this is something we do very early on in the process when we're modeling the data to try and figure out, what are the best algorithms to use to predict this outcome. So basically, they're having a competition. You can see there are 13 models that are going to be built. One has failed to complete. It's just fallen at the first hurdle. So it takes about a minute for it to do this. Eventually, all 13 hopefully will be built if they're not discarded, and it will retain the top 3, and we can see the top 3 models that it's chosen. And then we can see how accurate the top 3 models are on the test group, which will help us figure out which algorithms work best. And we can look inside the models, etc., etc. So this is a classic approach that people have when they're trying to build a model or trying to uncover insight to predict a particular outcome. The outcome here simply happens to be whether or not they're going to redeem a voucher. In reality, however, it could have been whether or not they're a good credit risk. It could be whether they respond to a mail shot. It could be whether or not they churn as a customer. There's lots and lots of different outcomes, and it just so happens to be, it doesn't have to be a 2-category outcome in this case. It could be a 3-category outcome, a 4-category outcome. It doesn't actually technically have to, in a lot of cases, have to be a category outcome. It could be a continuous outcome where you're trying to predict revenue, where you're trying to predict, an individual value, such as how much money people are going to spend. But in all these situations, we've got a similar thing going on, which is that we've got historical data with a known outcome, okay? And we're going to use this historical data to uncover a model to then apply it to some new data where we don't know the outcome in order to predict that. So here it's built all 13 models. It's retained the top 3, and I'll just show you how well it's doing here. So I look inside this nugget. It shows me the top 3 algorithms, and the first one here is what's called a C5 algorithm. The second one's C5, and the last one's called it's called a support vector machine. It's a machine learning algorithm. You can't see inside. It's known as a black box algorithm. And the moment it's using all of them, and the reason it's chosen them is because of this value called the lift value, which is basically related to the accuracy of the model. And you can see here it's based on the testing set. If I go to the training set, it's actually quite stable. Sometimes when you look at the training set, you find out that one of these models does better on the training, but does worse on the test. But it looks like it's pretty stable. If I look at the first one here, the C5 model, first of all, if I look at this little chart, the chart is telling me how accurate it is. So it's saying for those who did redeem the voucher, the green indicates how often the model accurately predicted them to redeem the voucher. So we can see the vast majority of the time it was accurate. There's a few errors up here. The blue is the error in the model. Over here on the people who did not redeem the voucher, the green represents the error, because of course Blue means that they were predicted to not redeem the voucher. Blue means 0. So this is the error in the model. And as a result of that, that model is about 80% accurate overall. If we look inside the model itself, we can see that the model exists as a series of rules. So there's a bunch of rules. I've got rules for, here's a rule for number 1 for people who redeem the voucher. And it's saying, if they haven't bought kitchenware, but they have bought furnishings, and they're in this age group, then I predict them to be a person who redeems the voucher, because 96% of them redeem the voucher, and there's 399 in that group. So it does a smash and grab raid and shows a whole bunch of rules. Down here, the model shows it as a tree of rules, a hierarchy of rules, where we can see the proportion that redeem the vouchers in this test set, 43% versus 56%. And it's splitting them by age group and by whether or not they've bought garden or outdoor. These two can be turned into rules until eventually it runs out of cases. So it's almost like a filtration system. So we can take this model here and we can actually, play around it, and we can apply it to new data. So for example, here, if I go down here to this example here, here's scoring data. Here I've got a C5 model already attached to some new data. Let's just hit preview up here. And this new data, we call it October campaign home goods, because this is data for the October campaign. What we don't have in it is we don't have an outcome saying whether or not they redeemed the voucher, because they haven't been offered the voucher yet. So if we run this model through it, what the model does is it produces, and if I just hit preview at the top up here, it produces scores for us. It produces predictions just in the same way that the association model we saw earlier on. So here's the prediction. I predict this person to be a redeemer. I predict this person to not be a redeemer. This is how confident I am of that prediction. 82% confident they'll be a redeemer. 35% confident they won't be. So we can use these confidence scores and these predictions to select the people with the highest propensity to redeem. So everybody up here has a very high propensity to redeem. Let's say that the offer is quite an expensive offer. So we only want to offer it to people who have a high propensity redeeming. So if I say, I'll just slice it at that point and select everybody above that point, then it will select everybody with a high propensity, where propensity value is greater than 5.52. Let's make it 0.55, just for the hell of it. And that will produce, if I hit preview again, a list of IDs with their propensity value, their likelihood to redeem. And of course, our decision point of that is then to send that out into a database, perhaps for our campaign management system to create. We're calling it the autumn voucher campaign. And in fact, Modeler even writes the whole stream out into SQL. So it's basically authoring the model and authoring everything it's doing there, and it's sending it, putting it back inside the database for it to be executed in the database, which just makes it more efficient, basically. It means that it's not dragging the data out. We can switch that on or off. It doesn't have to happen inside the database. And we don't have to work with databases. We could be working with flat files, text files, Excel files, etc. So that's a little example. There are two predictive algorithms. One is predicting what was the next best offer, and the second one is predicting, what was the propensity to respond to a particular offer, a voucher redemption. So when we think about, what good practice looks like, generally taking a step back from the modeling process, what I've done there is I've focused in on one part of a much wider process, which is the modeling bit. It's the fun bit. But in order to get to that point, we have to usually do a bit of planning, and we have to do an awful lot of preparing and playing around and wrangling with the data, because normally the data hasn't been collected with analysis in mind. Secondly, we had to have a very clear understanding of how we're going to evaluate the model, how accurate the model is, for example. We didn't really look at the accuracy of the models in any great detail, but we had some sort of sense of how we're going to deploy them. We talked a little bit about producing predictions and sending them out to a website or something like that to show images, or sending scores out to a database to be picked up by a campaign management system. So there was some sort of sense of deployment. And basically, there is a methodology that describes the entire end-to-end process, and we call it the CRISP-DM methodology. So our clients in Smart Vision, who are pretty good at this type of thing and who've gone down this journey of predictive analytics, they make good use of the CRISP-DM methodology, because it's the route map of how to, how to be successful within planning a predictive analytics application. It's not the only methodology. There are other ones out there, but it's a pretty good one, and it has its own website. So if you're thinking about setting off down the predictive analytics pathway, a very good start point is to look at the CRISP-DM website, because it will describe in detail each of these phases and what you need to do in order to ensure success. The second thing that our customers tend to do, the ones who are very successful, is that they tend to reach a little bit further in terms of the data. They don't just look at transactional data and scripted data. They look at interaction data. So they look at how often somebody visits a website, how often they email, when they did email, what they said, whether they've walked into a store. In other words, how they interact with the business itself. And that's important because, that may be another data source that they haven't really considered. People tend to think that, you deploy predictive analytics against one nice clean data source, but actually you tend to cobble together lots of different data sources of various quality. They may even use things like social media data, attitudinal data, data from surveys. The data may be structured and unstructured, but the more data that they can bring in that is pertinent to that application, then the greater the degree of intelligence they will have. It's driving the behaviors and predicting outcomes, but also the greater competitive advantage they will have over competitors who are maybe also using analytics. So, if you can exploit a wider data footprint, then you're probably going to be a bit more successful. The other thing is they tend to think about is what happens to the results. Where do they send the results? The results aren't just evaluated, hopefully, by an analyst, an expert analyst in predictive analytics, but rather they are deployed back out to a system that drives insight, that drives some sort of decision making, such as an asset management system or a workforce maintenance system or a CRM system or a campaign management system. It has to be something that enables decisions to be made. So they tend to think about integration of those results with existing systems. And there are a bunch of common misunderstandings that your data are not up to it. That normally people think, well, our data has to be perfectly clean, or we have to wait for the database to be ready or be overhauled before we can use it, or that you need to be a PhD in data science, or that it's very expensive, given that some of the tools out there are actually free. The last thing, probably the worst thing, is to think that it's all about algorithms. Actually, the algorithms sometimes are almost trivial part of the process. The biggest part of the process is planning it and thinking about what you're going to do, what the data needs to look like in order to make the decision, in order to uncover the outcome. The algorithm part of it is really not something that most people running these projects think too much about when they start off in them. They're thinking very much about what they would do differently if they were able to estimate that outcome, if they were able to generate that essential piece of data that predictive analytics applications generate. And the advice to get started, well, think about building internal credibility. Think about where you get the biggest impact for the least effort. Where are the obvious things within your business where you could perhaps bring this to bear. Have a meeting, talk to your colleagues. Consider adopting a proven methodology such as CRISP-DM. Don't get hung up in modeling techniques. Within the CRISP-DM process, focus on the business understanding phase and the deployment phase, the start and the end of the project. Very important to think about the start and the end of the project first of all, rather than thinking too much about the plumbing in between. Consider a wide data landscape. Consider all the sorts of people and roles within the organization that may be involved or impacted. Do IT have to be brought on board? Do marketing have to be involved? Consider integration with other business insight systems. Why not send the scores that you're producing, these predictions, probabilities, insights, anomaly values, back out to your existing BI systems, whether it be Cognos or Business Objects or Tableau. Very much important, how will you know it's worked? Focus on measuring the benefit. So doing a control test, example, measuring the response rate lift, increased cross-sell, or the impact on revenue or profits. And lastly, check out our website, because we've got lots of materials and videos on there, which will hopefully inspire you or give you some good advice on how to execute your own project. With regard to working with us, you can get software directly from us. So you can buy it directly online. So or talk to us. So by all means, just go and check that out. We offer a full range of training and consulting services, whether it be classroom training. We even offer services with regard to identifying and recruitment of people with analytical skills. And we generally offer no strings attached technical advice and technical support services around SPSS and SaaS software. I hope you find that useful. I do hope you tune in again at some point. We'll be running webinars throughout the rest of 2018. We'll have a couple more on today. But in the meantime, thanks for joining us today. And although it isn't the weekend quite yet, I do hope you have a great weekend. Take care and see you soon.